focusing really on the materials, the machines, and the processes that we can offer as a company. So PEL, Printed Electronics Limited, it's fairly self-explanatory what we might do in this sort of environment. We focus really on high-value engineering applications, fast turnaround, and generally non-consumer type of applications. We're a process and product development company. We're actually based inside the UK's largest printed circuit board company. So we're based here in Tamworth in the West Midlands in the UK. So all of the last presentations are very relevant to us because we see both sides. So we see day-to-day PCB manufacturing on a daily basis, and also we know what we do in printed electronics. So we can assist really with production scale-up in printable electronics, whether it be flat or 3D and conformal. But over the years, as we've learned how to do printed electronics over the last many years, we've also got very close relationships with a number of equipment suppliers. And generally the equipment suppliers that we've used, some of those we've become distributors or agents for as well. So I want to show you a little bit of that. And these are some of the machines that we sell and support at the bottom. And these are some of the other things that we do we don't really get into in this brief presentation. But as a business, our main focus is manufacturing. That's our day-to-day thing that keeps us busy. So we manufacture sort of small to medium scale, high turnover products, things that can be made in very short time scales with the equipment and materials that we have. And we also work in these other areas as well. You've already seen screen printing. It's easy to think of screen printing as an old technology, but actually over the last 10 years particularly, there's been enormous strides in improvement in screen print meshes, screen print capability. And we regularly sort of print circuits down to, well, very regularly down to sort of 100 microns or so, and down also to perhaps 30 microns on this system that we have here. So we, over the years, we've represented Micro-tec as a Japanese company who make this particular screen printer here. So we use very high spec screens to make very high spec products. It's all sheet to sheet. It's all relatively small format. Sort of A3 would be the biggest size format that we do. But in the medical and sensor market, there's been an awful lot of growth in that in the last few years. So these are just some pictures really of the things that we can show, because we can't show most of the things we do. But if you're interested in fast turn, small to medium volume precision screen printing, then please don't hesitate to get in contact. I'm sure we can help there. But as I say, the most important part of that really is that we built up a relationship with Micro-tec, and we also sell their machines. So we have one of these, actually a 550, which is a slightly smaller version of this. But we've also sold machines into academia. Here's a machine that we sold into the University of Manchester. It's in the Graphene Engineering Centre, the GEEK. I'll just turn the sound off. Sorry. So this is an example of Micro-tec's very large format, high precision screen printer. So here we're printing around about, 800 millimeters is probably about the maximum sort of size we can print here. And this is a 50 micron track. So it's a very large format, very capable screen printer, which the guys at the Graphene Centre over in Manchester are using very well now. But screen printing isn't the only thing that we focus on. We actually started with this, Inkjet, and we work very closely with IMI in training courses on general inkjet. So in Inkjet, we work on process development, industrial training, ink formulation through our capability, through our Cambridge office. In Cambridge, we have a small ink formulation facility run by my colleague, Claire Conboy, who many of you may know. And with Inkjet, you can definitely print very high resolution circuitry down to perhaps 100 micron tracking gap or so, perhaps even smaller on specialist substrates. And within Inkjet, we do many things, but one of the things that's probably most relevant to the community here is that those people doing Inkjet in this community will probably be using one of these, a Dymatics DMP. We, in the very early days, needed a UV curing system for a Dymatics DMP, and the available ones were kind of big and bulky and didn't really work so well. So we designed and built our own, and now we've sold around 100 of these globally. So this is our PEL UV curing system, which some of the universities here will already have, and for those who haven't, this is the plug. So this is the UV curing system. It normally sits inside the platform, but basically Here's an example of us using it at an IMI course to show a UV photofluorescent ink that we developed. So the system at the top is simply showing the capabilities of the platform that we make and sell. And then if there's time at the end, and if anybody's interested, I can show you a real live one. So that's screen printing, which gets down to maybe 30 microns, but commonly sort of 100, 200 microns. Inkjet maybe down to sort of 100 microns, perhaps 50. But what if you want to get down smaller? Well, the technologies that are out there that are available for smaller than Inkjet can do capability include Aerosol jet and this one, Super Ink Jet. So within the community here, connected to Inline, there are two machines that were installed in the very early days of the centre. One of them in Manchester and one of them in Cambridge. But recently, we also installed a much larger machine in Glasgow in Ravinder Dyer's group. And this is a photograph of the larger format SIJ system from the Glasgow facility. And this one particularly has a lot of other functionality on it too. It has plasma treatment, it has laser profiling as well built in. So Super Inkjet is a very capable technique used for getting 1 micron and perhaps even less than 1 micron lines and features. And I won't go into too much detail on here because actually, as I say, it's already being used in a number of centers within this community. If you don't need 1 micron, but maybe 10 micron, 20 micron, 30 micron sort of features is where you need to be and you want to do it in a cost-effective manner, then this is a platform that we sell and support. It's from it's from IDS NanoJet. That's a quick plug for Matthew there earlier on. This is from IDS NanoJet, and it is an aerosol jet system. It is a relatively simple system, and therefore it is lower cost than some of the other alternative systems, but it's very, very capable. This system can be sold as a head unit on its own, so you can incorporate the head unit into your own platform, or you can buy a number of different desktop or self-standing platforms. As you can see, it uses the same sheath gas approach that was in the previous presentation from Matthew. So this is a technology that can be used for fine lines in the tens of microns sort of range. However, as I said at the start, we do a lot of screen printing. And the reason we use screen printing is because the inks that we use for screen printing are very good inks that we understand well. And we understand them well because they're very viscous inks. They give a nice thick coating, but sometimes we would like a digital process for putting down a screen print type of ink. So here's another platform we built and designed ourselves. It's a 4 and 5 axis platform for printing viscous inks using a non-contact jetting system, which is not inkjet. It's a piezo jetting platform, but it's not inkjet. And this is our platform. This is it printing on a flat format. So here we're jetting down a very thick deposit. You can see this antenna here being actually in a single pass prints a very thick deposit around 100 microns or so. So very good for antennas. We can use it on curved surfaces as well. And we make a number of different formats of this machine. Small format like the one I'm showing here, which is at the University of Warwick. And it can be useful for printing a number of different materials. This is a model fluid, but could equally well be a biological material. And as you can see, it's a non-contact process. And here's a more extreme example of a non-contact printing. So here we're showing from a few millimeters away the printing of a silver nanoparticle ink for an array design for a customer of ours, which was initially printed on a flat surface, but also we printed that onto a curved surface as well, as you can see here. So this is what we call the 3D SP platform, 3D surface printer. And it's really geared around printing onto a 3D surface, maybe an existing 3D surface. And that's very good, but it doesn't cope with complete full 5-axis printing operations. And in that area, we partner very closely with Neotech AMT. Neotech AMT are a German company who make a very, very high performance 5-axis, full 5-axis platform onto which you can use that same type of printhead I just showed there, or the NanoJet system, or an inkjet system, or various other combinations. And Neotech AMT have a number of different demonstrators that they've shown and a number of different machines that perform all these tasks. And here's an example showing an egg timer, which is built on the same platform using fused deposition modeling, using pick and place, using jetting deposition, and it will also use the NanoJet platform as well. And the real key benefit of the Neotech platform is the very, very strong integration of the CAD and the CAM. The CAD here is shown on the left, where you can design your circuit in full 3D in a really very well integrated CAD and CAM platform, and then transfer it to the motion system, which allows the system to be built up. This is a system that's one of the systems that's in the UK. It's fairly local to us here in the Midlands. It's within the nuclear AMRC in Derby, affiliated with Rolls-Royce and the University of Sheffield. So that's the full 5-axis platform. If you need a simpler motion platform for putting your own print method, generally a 2D print method, then we also have designed and made this motion platform, which is a general purpose 2+1, sorry, it's an XY, but with a minimal Z-axis capability. So Z-axis of around 50 millimeters. And it's a relatively low-cost platform, which has got a web-based control interface and uses essentially some relatively straightforward 3D printing control software in order to do multiple things. And this particular platform here, we used in our PCB manufacturing facility for measuring the thickness of copper panels. So this is part of our equipment and material sales portfolio, where we design and build bespoke systems and platforms. So in summary, thanks for staying around. We're a manufacturing company. We do all of the things I've shown already and more, because there's things we can't show. We sell equipment. So if any of the things that are interested, that I've shown so far are interesting to you, then please get in contact. And we also do process control, process and product development, and also industrial training. And I don't know how we're doing for time, but if anybody's interested, I can actually do a live walk through the lab if that's of interest to anybody here. So thank you very much for your time and attention.